Well, hello 3C. Today we're going to be expanding and simplifying. Our goal, I know how to expand a polynomial expression with the distributive law, and I can collect like terms in order to simplify the expression. In order to reach that goal, we're going to talk about collecting and combining like terms again. This is stuff that goes back to at least grade 9, but we're just going to review it to make sure that everybody remembers what we're talking about. So, collecting or combining like terms. A question that requires you to combine like terms will have the word simplify somewhere in the question. So it says simplify the following. Now, what does simplify mean? Well, it means that we need to put together. And we're going to put together anything that is the same. And in math terms, putting together anything that's the same also means collect like terms. So I'm going to pull this down a little bit. What are like terms? Like terms are any terms that share the exact same variables. This means the variables must have the same exponents. So I'm just going to talk about this expression up here first. What does a term mean? What's a variable? What's an exponent? Do you remember all of that stuff? Well, a term is something in a math expression that's separated by pluses and minuses. So in this particular question, we've got 1, 2, 3, 4, 5 terms, and those terms are all separated by either a plus or a minus. So that's what a term is. As far as variables and coefficients go, variables are these things here, the letter terms, the things that the letters in the term, the things that we don't know. And that also includes this too, because when we have something like x squared here, that just means that we actually have two x's side by side, but that gets a little bit complicated to write. So it actually means x times x, so we put an x squared instead of writing out all the x's that are there. It's especially helpful if you end up with, say, x to the exponent 10. You don't want to have 10 x's on your screen. So now what are like terms? Like terms are any term that have the exact same variables. Now this actually means the variables must have the same exponents as well. So I'm going to highlight these words here. They have to have the same exponents, same variables, same exponents. So let's take a look up here. Do we have anything that has the same variables with the same exponents? Well, we have an x here and there's an x here. Now the problem is those two things aren't like because this term has a squared and this x doesn't have a squared. Also, this term here has a y, so that's not going to work. Okay, those two things are not like terms. So here's the kind of thing we're looking for. We're looking for, here I have an x squared term, and here I have an x squared term. So these two terms here that I've now got purple on their, the purple highlighter, the pink highlighter on their x squared, those are like terms. So I've got an xy here and an xy here. Those are like terms as well. And then the 6x, it doesn't go with anything because it doesn't have the same variables and the variables have the same exponents on them. Okay, now that we've identified what the like terms are, how do I combine like terms is the next question. So identify the like terms, which we have done, and then combine into one simply by adding the number that is with it. Now, the other term, the mathematically correct term we use for the number that is with it, is called the coefficient. So I'm going to be saying that word a lot, so you got to know what it is. The coefficient, the number that is with the term. Now, when we're doing that, we need to pay attention to the sign of that number and obey integer rules. And we also have to know if there is no number in front, we understand it to be 1. This is important. There's lots of times that you will see no number there, and we have to understand that it is 1. Okay, so here's the first thing we're going to do. This is the first one that we were talking up higher, is it? 5 terms. 1, 2, 3, 4, 5. Yep, it's the same one. Okay, so I'm going to use my pen And I'm just going to underline the terms that are like, and we already identified this. So we've got an x squared and we've got an x squared, and then we've got the 3xy and the 7xy. Now if you want to, you can write them down side by side. You can write 2x squared minus 5x squared plus 3xy plus 7xy minus 6x. You can swap them around. Just make sure that the sign that was with it, see this is minus 5x squared, it's still minus 5x squared down there. Okay. And now once you've got them all, you've got them combined, you've got them collected, we got to put them together. So 2x squared minus 5x squared, 2 minus 5 is negative 3. And of course we still have those x squareds there. And so that took care of those. Now these two ones, 3xy and 7xy, gives me 10xy. And then of course this minus 6x didn't have anything to go with it, so we leave it as minus 6x. Now when we're doing this, we're going to make sure we put equal signs out in front of each row, and we go down. Don't go across the page, go down the page. So now let's have a look at the next one. I'm going to use green this time. We've got a y cubed. No other term has a y cubed, so I don't have to worry about that. This one has an x squared, and this one has an x squared, and this one has an x squared, and they all also have one y. So all three of these things are like terms. And they're already written one right after the other, so I don't have to worry about grouping them together. So I'm just going to take a look at it. This has nothing to go with it, so I'm just going to write it down, xy cubed. Then I've got a positive 1. I'm going to put the positives together first. This, remember, there's nothing in front of there, so we understand it to be 1. So I've got a positive 1x squared y and a positive 7x squared y. That means I've got 8 positive x squared y and 6 negative x squared y. Now remember, when positives meet negatives, if I put a positive 8 with a negative 6, and it doesn't matter whether I write it that way or not, when I put a positive 8 with a negative 6, the 6 negatives are going to take out 6 of those positives. And if I take out 6 of those positives, I'm left with 2 positives. So we say plus 2 x squared y. And then this minus 8 has nothing to go with it. So I'm going to quick recap. I put together the positives first, so 1 plus 7 gives me 8, and then I subtracted the 6 to bring me down to 2. Okay. All right, so that's collecting like terms, or in other words, simplifying. Now, using the distributive law, I'm going to go back over what the distributive law was in the first place by doing it on something that has no real need for the distributive law, because we could have done it back in grade 9 or even before that with order of operations, or BEDMAS. BEDMAS tells us that I have to add the two things together before I do multiplication, because there's an understood multiplication in there, remember? If you have just a number out in front of brackets, there's a multiplication. So 5 plus 2 is 7. And then I have to multiply that by 3 according to BEDMAS. You do brackets, then you do the multiplication, so the answer is 21. But let's take a look over here with the distributive law. This is the distributive law. The distributive law says I can actually do the multiplying before I do what's in the brackets. I can, as long as I multiply everything in the brackets by that number out front. So that gives me 15 plus 6. And 15 plus 6 is 21. So look at that. We got the same answer. Okay? So the distributive law gets us to the same spot in just a slightly different order. So the distributive law gives us a way to get around order of operations when brackets are involved. This is good when there are variables in the question, because we can't add terms that aren't like. So here we go. Let's have a look at some that have variables in the question. This says expand and simplify when necessary. So that probably means that some of these won't need simplifying. So here's how we expand. I take the 2 and I multiply it through. So when I take the 2 and I multiply it through, I go 2 times x. Well, 2 times x I can just write as 2x, because we understand there's a multiplication in there anyway. And then 2 times 3y, well, I just have to multiply the 2 by the 3. So I have plus 6y. And that's all there is to it. Just multiply it through. We're basically multiplying the 2 by all the coefficients. And remember, we understand there's a coefficient of 1. So 2 times 1 gives us 2, and 2 times 3 gives us 6. Now, next we're going to multiply the 2x through. Now this has an x with it, so we got to be careful. We do 2 times 3 is 6, but when I do x times x, remember what I told you in the last one? X times x actually equals x squared. So we go 2 times 3 and x times x is 6x squared. Now 2x times 4 is just going to be 8. This 4 doesn't have another x to go with it, so this is just going to stay as 8x. Now the last one's quite a long one. I've got 2 different spots here, and look at this, I've got a negative in front here. You got to watch when there's a negative in front. Remember, when you multiply by a negative, it switches signs. So I'm going to multiply this 2x through this set of brackets. It doesn't go into this set of brackets because it's only in front of this set, and then there's this plus separating this out. So here we go. Negative 2x times x is negative 2x squared. And the negative 2 times positive 4 is negative 8. And if I have 1x here multiplied by 2 x's, this is what this is, 1x multiplied by 2 more, that means that I actually have x cubed. And now over here, I'm going to switch colors here just so you can see this part. I'm going to multiply the 3 through this bracket because it belongs with this bracket. So that's going to be plus 3x squared, and then 3 times 2 is 6, so plus 6, just 1x there. Now remember, it said simplify if necessary, so we have to look for like terms here. And there's not very many, but there is one. There is this negative 2x squared and a positive 3x squared. When I put a negative 2 with a positive 3, I get a positive 1x squared. Now you don't need to put that 1 there. Normally I won't do it. Okay, so we'll take that 1 away from that. So we've got a positive 1x squared. And now I've got negative 8 going with positive 6 is going to give me negative 2. Oh, nope, hold on. I can't do that. I heard somebody yell, hey, Mrs. Caldwell, that's not right. We can't put those together because this is an x cubed and this is just a plain old x. So what do? Since we can't put them together, we just write them down. Negative 8x cubed plus 6x. It's got nothing to go with. They're going to stay where they are. And that concludes this video.